In the last lecture, we were talking about exact differential equation. So I will just revise what we have seen in the last lecture. What is meant by exact differential equation? The equation of the type m dx plus n dy equal to 0 is said to be exact if and only if dou m by dou y equal to dou n by dou x. Dou stands for the partial derivative. Partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Then and then only the form m dx plus n dy equal to 0 is said to be exact. Then how to solve the exact differential equation, that also we have seen in terms of examples. The formula for solution is integral m dx, while taking the integration keep y constant, plus integral n dy, and here take the terms from n which contains y only. No mixed term should appear. Then we have seen the examples also on exact differential equation. Now, as per our syllabus, the next and the last type is linear differential equation. So the form is, a differential equation is of the form dy by dx plus py is equal to q. It is called as linear differential equation, where p and q are functions of x, where p and q are functions of x but not of y or constants, and the solution for that is y into e raised to integral p dx. Y into e raised to integral p dx means y into if is equal to integral q into if plus c. What is if? If is integrating factor, and formula for integrating factor is e raised to integral p dx. So I will just revise. Linear differential equation is of the form dy by dx plus py equal to q, where p and q are either functions of x or constants. No y term should appear in p and q. And to solve such type of equation, the first step is to find integrating factor. Integrating factor means if, the short form, and the formula for if is e raised to integral p dx. So once we find integrating factor, the solution is y into integrating factor is equal to integral q into integrating factor plus c. Alternatively, if the equation is like this, dx by dy plus px, we say it is not p, say p dash, and this one is q dash, where p dash and q dash are functions of y, not functions of x, and or constants, where p dash and q dash are functions of y only, not functions of x. And the solution for such equation is x into if is equal to integral q into if. Integration is with respect to y plus c. C is a constant, plus c. And integrating factor here is e raised to integral, instead of p dx it is p dash dy. Instead of p dx it is p dash dy. So just keep in mind that change. If the equation is of this form, the solution is this one. If the equation is of this form, the solution is this one. Then we try to solve some examples. Our first example is solve x into x minus 1 dy by dx minus x minus 2y is equal to x square into 2x minus 1. We try to make the equation in the form dy by dx plus py equal to q, or dx by dy plus p dash x is equal to q dash. So both options are open for you. but here the term is dy by dx and y is alone here, and therefore by simple logic we can say that it is of the form dy by dx plus py equal to q. Then to determine p and q, we divide throughout by x into x minus 1, so that the form is like this: dy by dx plus py equal to q. What is p? P is minus x. What is with y? That is p. P is minus x minus 2 divided by x into x minus 1. Q is x square into 2x minus 1 divided by x into x minus 1. So once we got this form satisfying the given conditions, then we say that the given differential equation is linear. And once we determine the type of the equation as linear, to find its solution, our first step is to find integrating factor. So integrating factor is e raised to integral p dx. So e raised to minus integral x minus 2 into x into x minus 1 dx. So this integration you can solve by partial fraction method. You know it from our integration topic. Then for that a, b, etc., and finally you will get integrating factor as x minus 1 divided by x square. So these steps are from integration. I suppose you are perfect in integration, and therefore its solution is, our formula for solution, y into if is equal to integral q into if dx. So y is this one, y into if is this one, and integration q is this one into if, and finally we will get this as integral 2 minus 1 upon x dx, and therefore the solution is y into x minus 1 is equal to 2x cube minus x square log x plus cx square. This one is the final solution. So here I will tell you one must be perfect in integration, because all these topics, they are from calculus, and calculus starts from sets, relations, functions, then limits, then continuity, then derivative, then integration, and then differential equation. So these are interdependent, means if you are not knowing integration, you cannot solve the differential equation. If you are not knowing derivative, you cannot integrate, you cannot solve the examples on integration. If you do not know the limits, you cannot solve the examples on derivative, and so on. So be perfect in all these topics. Second example is dy by dx plus y cot x is equal to cos x. So this one is simple. No rewritten is required here. No simplification, no adjustment. The equation itself is of the form dy by dx plus py is equal to q. What is p? P is cot x. What is q? Q is cos x. Both are functions of x, and therefore we say that the given differential equation is linear. So once we determine its type, as I have told you, the first step is to find integrating factor. Integrating factor is e raised to integral p dx. So e raised to integral cot x. So e raised to log of sin x. E raised to log of sin x. Integrating factor is sin x, and therefore the solution is y into if is equal to integral q into if dx, as we have seen in the type. So y into sin x into integral cos x into sin x dx. So the example you can solve on this integration. This integration you can solve either by sin x cos x is equal to sin 2x by 2, or by this formula, put cos x is equal to t, so that and so on. Sin x is equal to t, so that cos x dx is dt, and so on. And finally you just obtain the equation, the solution as y into sin x is equal to half a sin square x plus c. Half a sin square x plus c. our next example is again the simple one. Solve cos square x dy by dx plus y is equal to tan x. So here some adjustment is required because the example itself is not of the form dy by dx plus py is equal to q. So what we have to do, we have to divide throughout by cos square x so that dy by dx term remain alone. So dy by dx plus 1 upon cos square xy is equal to tan x upon cos square x. dy by dx plus integral 1 upon cos square x is sec square x, sec square y is equal to tan x into sec square x. So what is p? This is of the form dy by dx plus py is equal to q. So p is sec square x function of x, q is tan x into sec square x again function of x, and therefore we say that we conclude that the given differential equation is linear. And once we determine its type, as we have seen in the first two examples, to find integrating factor is our next step. So integrating factor is e raised to integral p dx, e raised to integral sec square x dx, e raised to tan x. So e raised to tan x is your integrating factor. The solution is y into if is equal to integral q into if dx. So that is y into e raised to tan x, integral tan x into sec square x e raised to tan x. So by substitution method, you can solve this integration, you can evaluate this integration, and finally you will get the answer as y is equal to tan x minus 1 plus c into e raised to minus tan x. So this one is the final solution. The next example is solve x log x dy by dx plus y is equal to 2 log x. Again, the example is not itself in the form dy by dx plus py is equal to q. Some adjustment is required. You have to divide throughout by x log x so that dy by dx remains alone. So dy by dx plus 1 upon x log xy is equal to 2 log x. Some mistake is here, so I will correct it. This one is equal to 2 log x. So example becomes like this, so that it will be of the form dy by dx plus py is equal to q. P is 1 upon x log x, q is 2 by x. Again, p and q both are functions of x, and therefore the equation is linear. And then our next step is integrating factor, e raised to integral p dx, e raised to integral 1 upon x log x. So integrating factor is e raised to log of log x means log x, and the solution is y into if is equal to integral q into if dx, that is y log x integral 2 by x log x dx, that is 2 integral t dt. Again, by substitution you can solve this and finally obtain the solution as y log x is equal to log x bracket square plus c, or y is equal to log x plus c. So this one is your final solution. So stay home, stay safe, be careful, try to solve the examples, and keep in mind that your unit test 1 will be on 28. So be careful, solve the examples, whatever homework is given, and try to obtain maximum marks in the unit test. Best luck. Thank you once again.